So when we're trying to determine if this function ends up being linear or exponential, first, I always think it's easier to see if it's linear. So let's go ahead and take a look at what's happening with the y coordinates. Now, here it's increasing by 5, then by 10, then by 5 again, then by 15. However, you can exclusively look at the y coordinate if the x coordinate is changing by the same amount. But this is one of those tricky ones where notice even the x's aren't changing by a constant amount. You have by 6, then by 22, then by 20, and then by 140. Now that's a bit of a giveaway. The fact that, especially at the end, the increase was so significant, that makes it pretty clear it's not going to be linear. But if you really wanted to test it, you could do essentially what slope is, right? Change in y over change in x. So if I do 5 divided by 6, I can test that out and compare it with, let's say, this change of y over this change of x, which you can tell is going to be significantly different, and it is. So that being said, what we can do at this point is really rule out the fact that linear, because it's not. Instead, we know it's exponential, and then you could just look at the wording. If you're saying it's approximately increasing by a same amount every 10 seconds versus increasing by a percentage or some kind of multiplicative factor, exponential is always either increasing or decreasing by a factor. So it's multiplicative in nature, which could also be like a percentage. It's not going to be by a fixed amount. That's a linear concept. So we can eliminate that one just based on the wording not being accurate for a description of an exponential function at all. And so we get, by process of elimination, the correct answer is A.